This is Algebra 2, Lesson 5-7, the binomial theorem. You can use the pattern of coefficients and the pattern a to the n, comma, a to the n minus 1b, a to the n minus 2b squared, etc., all the way through, to write the expansion of a plus b to the nth power. For example, you can expand a plus b to the third as a plus b times a plus b times a plus b, and you can multiply it out and get a to the third plus 3a squared b plus 3ab squared plus b third. And this is what it's trying to tell you. Remember, a to the n, here was a to the n. Okay, you have your 3 here. And then it was a to the n minus 1, that's why this is 2, and then there's your b. And then it's a to the n minus 2, that's why this is a, and b squared, etc. As a goes down, notice b goes up. That's what they're trying to tell you. You can multiply those out to get that, okay? And then you can write it in standard form. But let's take a look at something. If I consider the expansion of a plus b to the n, the first few values of n, okay? Let's say, and we're going to start with row 0. If I have a row 0, I have a plus b to the 0 power, so its expanded form is just 1, and its coefficient is 1. If I have a plus b to the first, that means it's a plus b. Okay, which is 1a to the first plus 1b to the first, which is the coefficients are still 1. If I do a plus b 1a squared, I get a squared plus 2ab plus b squared. So that's 1a squared plus 2a to the first, b to the first, plus 1b squared. Coefficients are 1, 2, and 1, etc. We can continue to move this on, and you'll notice that the coefficients keep getting, because 1 stays there, and it stays here all the way through, but the coefficients get bigger, and then they go back to smaller. Okay, the coefficients only column matches the numbers in what we call Pascal's triangle. It was named after Blaise Pascal, and he's in a triangular array of numbers in which the first and last number of each row is 1, and each of the other numbers in the row is the sum of the two numbers above it. For example, and we have the diagonal of 1s right here and right here, and a nice little diagonal of 1s. But then, if you look at this, what is 1 plus 1? That's 2. What's 1 plus 2? That's 3. What's 2 plus 1? That's 3. What's 1 plus 3? That's 4. What's 3 plus 3? That's 6. What's 3 plus 1? That's 4. Notice how this works. 4 plus 6 is 10. 4 plus 6 is 10. Okay. 10 plus 10 is 20. 5 plus 10 is 15. So it gives you the pattern that you can continue. You can continue Pascal's triangle forever without me having to give it to you, because now you know the pattern. Now, there's an interesting way to use Pascal's triangle. Because you can use Pascal's triangle to expand a plus b to the 6th without having to multiply it out. A plus b times 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 a plus b, which I know for a fact would be incredibly tedious. Okay. Since the expression is raised to the 6th power, you use the 6th row of Pascal's triangle as your numbers, and then your variables are going to decrease and increase accordingly. Okay, so the 6th row tells you you're using the numbers 1, 6, 15, 20, 15, 6, and 1 again. And then notice what happens to the variables. The exponents for a start with 6 and then decrease. So you have a to the 6th, then a to the 5th, then a to the 4th, then a to the 3rd, then a to the 2nd, then a to the 1st, and a to the 0. While the exponents for b begin with 0 increase. So b to the 0 power, b to the 1st power, b to the 2nd power, b to the 3rd power, b to the 4th power, b to the 5th power, b to the 6th power. So when you simplify that, because anything with the 0 power is 1, we get rid of those. You get a to the 6th plus 6 a to the 5th b plus 15 a to the 4th b squared plus 20 a to the 3rd b to the 3rd plus 15 a squared b to the 4th plus 6 a b to the 5th plus b to the 6th. Aren't you glad you didn't have to multiply out to get that? That would probably take half a page of multiplying out longer. We're going to expand x minus y to the 9th. Now, realize that this was plus. So everything was an add. When you have a negative, okay, when you have a subtraction, the signs alternate. You start with positive, then go to the negative, then go to the positive, then go to the negative, then go to the positive, then go to the negative. The numbers in Pascal's triangle stay the same. You just make sure first term positive, second term negative, third term positive, fourth term negative, fifth term positive, sixth term negative, so on and so forth. So if I'm going to use this, okay, we are using the 9th row of Pascal's triangle, and I only gave you 7 rows, didn't I? Wasn't I a mean? Okay, I was just a mean. If you go back a page, okay, I only gave you 7 rows of Pascal's triangle. But we can expand it, can't we? We know that this is a 1 here, we know that this is a 1 here. So row 8, 1 plus 7 is going to be 8. 7 and 21 is going to be 28. 21 and 35 is going to be 56. 35 and 35 is 70. And then it goes back to 28, between 56 and then 28. Okay. 56, 28, and then 8. So that's row 8. All right. So row 9 would be a 1. 8 and 1 is 9. 8 and 28 is 36. 28 and 56 is 84. 56 and 70 is 126. And so that means this is 126. Then this goes back to 34. And this goes back to 36. And this goes back to 9. And then finally goes to 1. And that would be row 9. So the numbers we're going to use are these numbers right here. Okay, so let's go back over here. And we're going to expand. So the numbers that we're going to use in Pascal's triangle, we need the 9th row. And the numbers are, in the 9th row, the numbers are 1, 9, 36, 84, 126, 126, 84, 36, 9, and 1. Okay. So, remember, the A's and the B's are now replaced with X's and Y's. So it's going to be 1, X to the 9th power, Y to the 0th power, so I'm going to leave it alone. Minus, because remember what I said, alternate your signs because it's a negative. Now we're going to use 9, X to the 8th, Y to the 1st, because X is going down, Y is going up. Plus 36, X to the 7th, Y squared. This is probably not going to fit on this page because I wrote it today. Okay. Minus 84, X to the 6th, Y to the 3rd. Plus 126, now we're at X to the 5th, Y to the 4th. And then a negative 126, X to the 4th, Y to the 5th. I'm not confused. Why do you think? Okay, and then we're going to have 84 again. 84, X to the 3rd, Y to the 6th. And then negative 36, X to the 2nd, Y to the 7th. And then 9, X to the 1st, Y to the 8th. And last but not least, negative Y to the 9th. So that's the big, long, expanded formula. It's X to the 9th minus 9, X to the 8th, Y, plus 36, X to the 7th, Y to the 2nd. Notice X is going down, 9, 8, 7, 6, 5, 4, 3, 2, 1, none. And Y is going up, 0, 1, 2, 3. And that's how you expand. And that's a whole lot easier than actually having to multiply it out for itself. Using Pascal's triangle makes it fairly simple. Now, this just tells us that the binomial theorem just tells you that the numbers are in the nth row of Pascal's triangle. Now, sometimes in terms of a polynomial, have coefficients up there that wrong. You can still base the expansion to standard form on the pattern of a plus b to the n. Okay, we're going to expand x minus 2 to the 3rd. That's not huge, but it's big enough that I don't want it to multiply out by myself. Okay. The thing we should pay attention to is this would be the 3rd row of Pascal's triangle, which if you look at the 3rd row is 1, 3, 3, 9. Okay. 3rd row, 1, 3, 3, 1. Okay. So it would be, if I was just going to use A's and B's, it would be A to the 3rd minus, because it's a minus, so it's going to alternate signs. So A to the 3rd minus 3A squared B plus 3AB squared minus B to the 3rd. Now that's what it would be if it was going to be with just A's and B's. Now, we're going to replace the A's and B's with whatever we have here. So if we look at this, x minus 2, A becomes x, and B becomes 2. By alternating the signs, we don't have to make B negative 2. You could use all positive signs and put in negative 2, but I find that when the students do that, they make errors with their signs. So now I'm going to say, so if x is A, so I'm going to have x to the 3rd minus 3 times A, which is x, squared times B, which is 2. Notice now time putting that in there, plus 3 times a, which is x, times b, which is 2 squared, minus 2 to the third. And so now I need to actually do the math. So this becomes x to the third, no problem there. 3x squared times 2 is 6x squared, so minus 6x squared. 2 squared is 4, 4 times 3 is 12, plus 12x, and negative 2 to the third is negative 8. So we should get x to the third minus 6x squared plus 12x minus 8. A much easier expansion than having to actually multiply out x minus 2 times x minus 2 times x minus 2. For them, when they're as small as this, they're not hard, but when they get bigger, like this one, we expand 2x minus 3 to the fourth power. Okay, so we're going to use the fourth law of Pascal's triangle. Look back, the fourth law of Pascal's triangle says 1, 4, 6, 4, 1, 1, 4, 6, 4, 1. Okay, and of course, I'm always going to write it out to the regular form first. So that means it's going to be 1a to the fourth b to the 0 minus 4a to the third b plus 6a squared b squared minus 4ab squared plus, let's b to the third, excuse me. I almost messed it up. B to the third, b to the third plus b to the fourth. So plus, minus, plus, minus, plus. Okay, the signs are good. I'm going down with my a's, 4, 3, 2, 1, none. Up with my b's, 0, 1. I can put a 0 there. That helps. Okay, so now I'm going to plug in where a is equal to 2x and b is equal to 3. And I'm actually going to write this over here. A is equal to 2x, b is equal to 3, because I want to be able to write right into the problem. So I'm going to have 1 times a, which is 2x, to the fourth power, times 3 to the 0 power, minus 4 times a, which is 2x, to the third power, times b, plus 6 times a squared, b squared, minus 4 times a, which is 2x, times b, which is 3u, plus b to the fourth power. And now I get to do all the math. 2x quantity to the fourth is 2 to the fourth x to the fourth. 2 to the fourth, 2 to the fourth is 16. Anything to the 0 power is 1, thank goodness, so this becomes 16x to the fourth, minus 2x quantity cubed is 2 cubed, x cubed, 2 cubed is 8. 8 times 4 is 32, times 3 is 96, so this becomes negative 96 x to the third. I would suggest you use your calculator to make time do that. Plus, this is going to become 6 times 4x squared times 9. This becomes 4 times 8x cubed times 3. That's why I got 96. 9 times 4, 6 times 4, 24, 24 times 9 is 216. So I get plus 216x squared. Here I'm going to have 4 times 2x times 3 squared cubed is 27. 27 times 8 is negative 216 minus 216x. And last but not least, 3 to the fourth power is 81. So there I have the expansion of 2x minus 3 all to the fourth power without having to actually multiply out 2x minus 3 times 2x minus 3 times 2x minus 3 times 2x minus 3. And again, I will make you do this without using the graphing calculator, so you can't plug this in and go there with the form. You actually have to use the rules of Pascal's triangle and a basic calculator to be able to solve this. This is Pascal's triangle.